Hey students, this video we're going to be talking about ions, and we're going to be looking at how we can find trends on the periodic table and how we can determine what ions form from specific elements. So very similar to what we've been doing in the past few days, looking at location of the periodic table and being able to decipher more and more information, right? So in order to look at ions, we're going to look at how reactive elements are. And this is something Mendeleev did. When he started to first create the periodic table, he noticed that things in the first column, or group A, and elements in the second last column, group 7A, were both extremely reactive. Okay, so we're going to look to see why those two groups of elements are reactive. And he didn't even know about these noble gases, right? They did not. They weren't discovered till later on because, well, we can talk about that now. Because if we take a look at the molecular view of noble gases, we can see that we have helium, neon, argon, krypton. Their electron shells are completely full. Okay, so that means when the electrons are filling the entire outermost shell, you have an extremely stable element. And stable elements do not want to react with anything else because it's doing all right. It's doing well. It doesn't need anything, right? So it's kind of like if you would make a trade when you're not getting back anything that you need, right? Neon, argon, krypton, helium, they all have enough electrons to be stable, so they do not want to trade with any other elements. Helium has 2, remember? First energy level always has 2 electrons. That's our smallest energy level. And then after that, our second energy level, our third energy level, and our fourth energy level all have 8 total electrons before we move on to the next energy level. So because noble gases are kind of like better than other elements, it's not really better, but they're more stable than other elements, we kind of refer to this as noble gas envy, because other elements want to be like the noble gases. They envy them. Meaning other elements want to have stable electron shells. So they're going to move, transfer, share, donate electrons to have a full outermost electron shell. Sometimes that's 2 electrons if it's the first energy level. Sometimes that's 8 if it's the second, third, fourth energy levels. So we take a look here at sodium and fluorine. Right, sodium is in group 1A. Fluorine is in group 7A. And we know based off the group number, that's how many valence electrons it has. So sodium only has 1 valent electron, fluorine has 7. So sodium here is going to want to donate or get rid of this electron, because if it does, then the last thing that's left, or the next energy level, is this second one. And this is it's completely full, right? So then it will be stable. Fluorine would then add the last piece to its puzzle. It'll have 8 valent electrons and its outer shell as well. So it will be stable. So this transferring of electrons from an element to another element creates our ions. Right, because now sodium has a +1 charge because it has lost an electron. And if we look at the neutron there, we have 11 protons. We have 12 neutrons, which doesn't factor into ions. And then if we had to guess how many electrons, we'd say, well, we have to have 1 more proton than electron because it has an overall +1 charge. So this would have to be 10 electrons. And with the shell models, we can literally just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? It's kind of like a kid's show. We're just kind of counting numbers, right? We know how to count. So this is good practice. Fluorine, on the other hand, gained an electron, right? So maybe this guy is the one that gained. So fluorine has 9 protons, 10 neutrons, and then this time now it has 10 electrons, right? Because now it has a minus charge, meaning it has one more electron than proton. It's very easy to get this confused because it has a negative charge. A lot of times students think it lost something. No. In chemistry, when you have a negative charge, you gain an electron. So now both ions have an electron arrangement like the noble gas neon, right? Because if we scroll back up to neon, right, neon has 8 valence electrons in the second energy level, right? Scroll back down. And we can see that both of them also have 8 valence electrons in 2 energy shells. So that's what we mean when we say noble gas envy, because fluorine and sodium, in this case, want to be like neon. They want to look like neon in terms of electrons, not in terms of protons, only electrons. So if we take a look at this problem, calcium oxide, if we consider this compound, we have to draw the shell model for calcium and oxygen. So the first thing I can do is go to my periodic table, and here it is. So we can go find calcium, and it's on the left side. It's in the second group, group 2A. And we can see it's in the fourth row, and it's in the second group. Meaning, when we draw this, we can go ahead and, let's figure out how many protons it has. Its atomic number is 20. Its atomic mass is, so it has 20 protons, that's its atomic number. It said the atomic mass was 40.0, so we'll probably just say 20 neutrons as well. Okay, so that's our nucleus. If we go back to calcium, we can see it's in the 4th period. Right, so that means it's going to have 4 energy levels around it. So we're going to do 1, and actually a little shortcut, I'll just paste them. Start dragging them to the outside. So we are not going to include this center as that's not our ring, that's just our nucleus. Right, so now we currently have 4 energy levels. We need 1 more. There we go. And now we can start including our electrons. So if it has 20 protons, it's going to have 20 electrons. So we just start on the first one, 1, 2, and then 8 every other one. 1, 2, 4, 6, 8. Go to the next one. And then if we look at the column or the group that calcium it's in the second, or 2A, so we know it has 2 valence electrons. Let's go ahead and put them over there. Yeah, so this is calcium. And then we can do oxygen, which is a lot smaller, so it won't take nearly as much time. But we go to the group. So oxygen is in group 16. It's the one on the top there. Its atomic number is 8. And it has an atomic mass of 16. So in our center, we have 8 protons. Its atomic mass is 16, so it's going to have 8 neutrons most of the time. Here's an oval, I guess. Just make sure that's a different color so that we know that's the nucleus. And then we can go ahead and include our energy levels. So we look again, oxygen is in our 1, 2, second row, right? It's in our second period, so we know it has 2 energy levels, 8 total electrons, and it's in the 6th group, so it'll have 6 valence electrons. So we go ahead and put our electrons in, starting in the innermost ring, 1, 2. And again, it's going to have 6 valence electrons, 2, 4, 5, 6. Right, so now it has 8 total electrons in its outermost energy level. Or, sorry, 8 total electrons in the atom itself. So that was A. For B, it says, with arrows, show how electrons can be transferred so that each atom has the same electron arrangement as that of a noble gas. So I'm going to actually highlight, move this closer. And actually, let's see, I'm going to get rid of these. I'm going to move the electrons on this side and just put them on the right so we can kind of see it a little bit easier. Oops. Okay, so we can see, or we know that calcium has 2 valence electrons. It wants to get rid of this electron shell. So these electrons want to donate. Oxygen needs 2 more electrons to become stable, so they're just going ahead and going to get donated over to where they would then be in the outermost energy level for oxygen, and then calcium will be stable, and then oxygen will be stable as well. Right? So then if we look at the last question, what are the charges on the calcium ion and oxygen ion after each electron has been transferred? So, let's see. Okay, so calcium has 20 protons and it just lost 2 electrons. So it's going to have, if we just look at this real quick, so 20 protons, 18 electrons. That calcium is going to have a +2 charge, right? This one was B. Oxygen just gained 2 more electrons, so it had 8 protons. It always has 8 protons. Started with 8 electrons, now it has 10 electrons. So our oxygen is going to be 2-. Okay, so we can see here through these shell models of electrons being transferred from one to the other. And I believe, yeah, so we're going to do a few more and then stop for this video. But we can look at trends or patterns on the periodic table and what ions form based off of what group they're in, right? So every element in the first group, 1A, will form a +1 ion. Every element in group 2A is going to form a 2+ ion. And we can see that going forward. 3+ for 3A. Group 4A, which is right in the middle, can either be 4+ or 4-. It's kind of more just hypothetical because these guys, carbon, silicon, germanium, they don't actually form ions. So we don't really need to worry about that too much. But as soon as we get to 5A, this is kind of our boundary. 5A, we are closer to 8, so it's easier to gain 3 electrons than it is to lose 5. So nitrogen, phosphorus, arsenic, these guys are going to form 3-. 6A is 2-. 7A, 1-. And then 8A, those are our noble gases, right? So they are our stable elements that are not reacting with anything. So this is an important trend to remember, okay? If you can remember which elements in which groups form which ions, then it'll save you a bunch of time and you'll be able to answer a bunch of different types of questions just from that simple fact. So as we see, elements on the left side, these plus charges, these are mostly metals, and they form ions with positive charges called cations. Elements on the right side, which are mostly nonmetals, tend to form ions with a negative charge called anions. Okay, so sometimes anions, it kind of sounds like onion. Onions make you sad. It's a teardrop. So they can make you negative or grumpy, sad. I don't know, something negative. All right. Cations, I don't know. Think of cats. This is a cat. Cats are happy, hopefully. So cats are positive or you can think of them as positive. See that? Yeah. So maybe 2 ways to remember it. I don't know. That's how I remember it sometimes. So we're going to pause there. The next video will cover ionic compounds, which is the second half of the notes. I hope you guys have a good day. Bye.